In 1905, Albert Einstein published a paper containing a special theory of relativity, also known as the theory of special relativity or simply special relativity for short. The theory explained how speed, mass, time, and space are all connected. It also introduced the famous formula, which is E is equal to mc squared. It stated that energy is equal to the mass times the speed of light squared. Special relativity applies to special cases. It's mostly used when discussing huge energies, ultra-fast speeds, and astronomical distances, all without the complications of gravity. Einstein officially added gravity to his theories in 1915 with the publication of his paper on general relativity.
Einstein's first postulate, the relativity principle. This postulate states that the law of physics are the same in any IFR. What this tells you is that no inertial frame is more correct than the other. Simply put, there is no absolute frame of reference exists in the universe from which motion can be described or compared to. The first postulate of special relativity states that the laws of physics and electromagnetism are the same in any inertial frame of reference. This implies that the experiments performed in stationary and moving inertial frames yield the same results. Einstein's second postulate, the constancy of the speed of light. The speed of light in a vacuum is same all in the IFR and is independent of the motion of the source. Although the speed of light changes when it moves through glass or water, it cannot go faster than 3 times ms its speed in a vacuum. The second postulate of special relativity is that the idea that the speed of light c is a constant, independent of relative motion of source. The Michelson-Morley experiment demonstrated that the speed of light in a vacuum is independent of the motion of the Earth about the Sun.
Mass-energy equivalence is the relationship between mass and energy in a system's rest frame where the two values differ only by a constant and the units of measurement. The principle is described by the physicist Albert Einstein's famous formula, energy equals mass times speed of the light squared. The formula defines the energy E of a particle in its rest frame as the product of mass with the speed of the light squared.
Albert Einstein's theory of relativity is actually two separate theories. His special theory of relativity, postulated in the 1905 paper, the electrodynamics of moving bodies, and his theory of general relativity, an expansion of the earlier theory, published as the foundation of the general theory of relativity in 1916. Einstein sought to explain situations in which Newtonian physics might fail to deal successfully with phenomena, and in so doing proposed revolutionary changes in human concepts of time, space, and gravity. The special theory of relativity was based on two main postulates. First, that the speed of light is constant for all observers, and the second, the observers moving at constant speed should be subject to the same physical laws. Following this logic, Einstein's theorized that time must change according to the speed of moving object relative to the frame of reference of an observer.
General relativity is a theory of gravitation developed by Albert Einstein between 1907 and 1915. The theory of general relativity says that the observed gravitational effect between masses results from their warping of space-time. Orbital shifts experienced by Mercury. The orbit of Mercury is shifting very gradually over time due to curvature of space-time around the massive Sun. In a few billion years, this wobble could even cause the innermost planet to collide with the Sun or another planet. Using Einstein's theory of general relativity, the precession of Mercury's perihelion should advance slightly more than under Newton's prediction. The Gravitational lensing. The Einstein cross, a quasar in the Pegasus constellation, is an excellent example of gravitational lensing. Light bends around the massive objects, such as a black hole, causing it to act as a lens for the things that lie behind it. The quasar is seen as it was about 11 million years ago. The galaxy that it sits behind is about 10 times closer to Earth. Formation of black holes are regions of space-time where gravity's pull is so strong that nothing, not even light, can escape from being dragged in and eaten. Einstein's theory of general relativity predicted the existence of black holes and that no matter what such an object, its black holes are characterized only by their mass, spin, and electrical charge. Astrophysicists refer to this as the no-hair theorem. Gravitational waves. Einstein predicted that violent events such as collision of two black holes create ripples in space-time known as gravitational waves. In 2016, the Laser Interferometer Gravitational Wave Observatory announced that it had detected such a signal for the first time.